Hi. These are my lessons in Calculus 1, and we're doing the homework now for section 2.8. So this is derivative as a function, so we're really kind of getting into the meat of the course. So just to have said it a couple more times, we're emphasizing that this course is about doing the problems. And so that's part of why I'm making every other video be doing problems, because that's what we're about. And then the second thing is I'm emphasizing is that you want to be, every time you do problems, you want to be making sure that some number of them, I try to do one problem per every 5, some number of them is going back to some prior section that you've done before and just revisiting it. I try to pick a number sort of in the middle of the pile and go through and do that problem. Sometimes it's easy, sometimes it's a little harder, and that way when you're trying to recall them, say on an exam or in another class, you're not like, oh, how does that go? Because it's fresh, you've kept recalling it. Okay, let's start in. Let's see here. So the first problem is from a prior section. It's from section 2.5, and it is number 23. Let's see if I can get it on the video. There we go. Number 23, and maybe I'll turn up the light a little bit. There we go. And it's a continuity question. So it says, the instructions over here, you can't read it because it's not on the screen, but it says explain why the function is discontinuous, sketch a graph of the function. And so they give me a function, and it's one of these 3y's functions where they say cosine if x is less than 0. So I'll draw a graph of cosine when x is less than 0. 0 if x equals 0. And then 1 minus x squared for x greater than 0. And they want me to talk about what happens at a equals 0. All right, let's see how I do drawing the graph of that. So let's see. I'm looking at f of x is there's 3 cases. Cosine of x if x is less than 0, and then if x equals 0, I'm looking at 0. And then a 1 minus x squared if x is greater than 0. Okay, and I know how to draw cosine and how to draw 0 and how to draw 1 minus x squared, so I think I'm ready to go. So let's see. So cosine looks like this, but I'm drawing strictly for x less than 0, so I'm making a sort of exaggerated open circle there. But for x is less than 0, cosine looks like so. Maybe I'll put in the rest. There we go. And for x is greater than 0, 1 minus x squared is a downwards facing parabola starting at y equals 1, so 1 minus x squared. But at x equals 0, we've got a value not of 1, but instead of 0. So it's one of these removable discontinuity cases, that's all. And then the question again says, explain why the function is discontinuous. And the answer is that the limit as x approaches 0 from below of f of x, that's the cosine part, it is 1. The limit as x approaches 0 from above of f of x, that's the 1 minus x squared part, that's also 1. And so as a result of these two, the limit as x approaches 0, no above, no below, just 0 of f of x is 1. But of course, f of 0 is not 1. Okay, so just reminding myself what continuity means, bringing it to my mind every once in a while, systematically trying to go back and look at prior sections over and over again. All right, very good. So now I'm working on the section that we're on, which is section 2.8. I got to turn the page to section 2.8, find my way there. So I do have a comment about section 2.8 while I'm flipping pages. Here we go. And that is that we're starting to get into sections that sometimes a person in this class finds to be hard algebraic manipulation. And that's true. I think some of these are hard algebraic manipulation. I deliberately picked 2 that are going to be relatively long. everybody has to learn hard algebraic manipulation somewhere, and for many folks, me included, this is it. This is where I learned it, and it would not surprise me if this is where you learned it. All right, so I'm looking for question 5 and question 7. It says trace or copy the graph of the given function and then use the method of example 1 to sketch the graph of f prime. So I'm going to do the best I can to sketch out the graph of this, and then below it I'm going to draw the graph of f prime, and likewise this. So let's see how I do. Okay, so the first one is kind of looks like a parabola, except that it's got a bump in the middle. So, so this is number 5, and we're looking at something like so. And bump. So over here and over here looks like a parabola, but it's got this bump at the root. And below it, I'm going to draw another axis. And I'll do my best to draw the the graph of the derivative. So I'm going to use red. I don't know what the heck. So so I am by eye figuring out what are the slopes here, and the easiest way to figure out the slope is to graphically to draw the tangent line and to say the slope is so and so. So right there, the tangent line is flat, so the slope is 0. Right here, the tangent line is flat, so the slope is 0. Right here, the tangent line is flat, so the slope is 0. Over here, the tangent line is going downwards, so the slope is somehow negative. Over here, the tangent line is headed in an upwards direction, so the slope is positive. Downwards, slope is negative. Upwards, slope is positive. So I'm doing the best I can, but I get a graph that looks something like so. Something like so. Okay, so I draw in a bunch of tangent lines and say to myself, slope positive, slope negative. I could say, slope looks bigger here, and so it's gaining. But anyway, slope positive, slope negative, and I connect the dots. It's that straightforward. Now, for number 7, I just had it up for a second, but you might remember that it looks like the upper half circle. And I'm going to do the same thing of above and below. It just seems to be sort of graphically convenient. Okay, and I'm eyeballing what is the slope is 0, so slope is 0. Slope is positive, slope is more positive, slope is more positive. So it seems to me the slope is quite positive, middling positive, like so maybe. Slope is negative, even more negative, quite negative. So slope is negative, even more negative, quite negative. Okay, maybe a tangent graph. Okay. All right, so just really a question on the concept of what derivative is about. We're trying to find the rate of change, and one way to interpret the rate of change of the function is as the slope of the tangent line. And graphically, that often turns out to be, convenient, often turns out to be an easy way to express what we're trying to do. All right, next up was number 23, and so I'm kind of picking a variety of questions, and in particular, in line with what I talked about at the very beginning, I tried to pick a couple of questions that are algebraically awkward, or that take a certain amount of doing, that take sort of 10 lines to get. So number 23, it says find the derivative of the function using the definition of derivative. So number 23 says 2.5 t squared plus 6t. I know the change in letter doesn't fool anybody. And I'm also going to do number 28 here. F of v is v over v plus 2. Okay, so let's see. I might want to pick a fresh piece of paper because I'm going to need lots of room. So let's see. Let's see. There we go. So f of t is 2.5 t squared plus 6t. Okay, definition of derivative, this is number 23. Definition of derivative says the limit as h goes to 0 of f of t plus h minus f of t all over h. So I'm looking at the limit as h goes to 0 of, it's going to be all over h, and I've got here 2.5 times 2.5 times t plus h quantity squared plus 6 times t plus h, and just trying to mark that off so a person's eyeball can spot the difference, and 2.5 t squared plus 6t. Okay, and before I go on, just a couple of comments here. The first is that I've mentioned a couple of times. I won't mention it every time, but more is better than less. The mistake that I'll see here is somebody will write something like 2.5 t squared plus h, and that's not right. The right thing is 2.5 t plus h quantity squared. And then the other mistake that I'll see here is that people will put the 2.5, people will put the t plus h in here, and they'll just put t here. And I can see why a person's in a hurry, want to get onto the other parts. I see, but that's wrong. You got to put t plus h everywhere where you would have seen a t in the original expression. Okay, so clearly I'm going to have to square that out and multiply through by 6 and etc. So new line, and I'm looking at limit as h goes to 0 of 2.5 times t squared plus 2th plus h squared. And again, I recognize, I talked about this a minute ago, I recognize that for some folks it doesn't come that fast. You know, I've been doing it for a living, but nonetheless, this is the course in which you start saying to yourself, you know, okay, getting better at this because I'm doing a lot of it. Alrighty, all over h. And then I'm subtracting the 2.5 t squared and also subtracting the 6t. Alrighty, now it seems to me that you know, we can spot some patterns, and there's always a canceling left and right. So here I go, I'm seeing some cancel, and it seems to me the 2.5 t squared cancels with the, I guess I'm not going to actually write the cancel. 2.5 t squared cancels with the 2.5 t squared, and the 6t and the 6t. So the next line is going to be the limit as h goes to 0 of, there's going to be a 2.5 times 2th, so that's 5th. There's a 2.5 times h squared, 2.5h squared. There's a 6h, and these other things have canceled. And now we're on familiar territory. So we know what's going to happen here. You factor out the h and you cancel with the bottom. So starting to feel like we found our footing here. Limit as h goes to 0. And again, just a caution, the mistake that I see people here, that they might cancel this h with that h and leave the h squared and leave the 6. That's not right. You have to factor the h out of every term. So 5t, 2.5h, 6. And now you can cancel the h's, and you've got the limit as h goes to 0 of 5t plus 2.5h plus 6. And of course, this is no longer got an h in the denominator, so you no longer have a limit of a denominator equals 0. So the difference between what's here and what's here, how come I can just plug in the h's, is because no longer do I have a fraction with a 0 for a denominator. So at this point, I can just plug in the h equals 0, and I got 5t plus 6. So it goes fast at the end because the whole job is to get rid of that somehow fraction with a limit in the denominator of 0. Okay, so certainly plenty of places where a person can make a boo-boo, and I will often hear from folks, you know, I never had to do a problem sort of this big, never had to do a 1, 2, 3, 4, 5, 6, 7 stage problem before. Okay, well, you know, hello, welcome aboard. All right, so the next one, I'm not going to flip back to the book. The next one is f of v equals f of v, it's a capital F, I'm just copying what the book says. It's v over v plus 2, v over v plus 2. So again, I'm taking the limit, and this time I find myself looking at the limit as h goes to 0 of, it's got a fraction on the top, so it's a little bit complicated. So I'm going to leave a little extra space for a person's eyeball to spot the pattern. I'm taking where it says v, and I'm plugging in v plus h. So v plus h on the top, and where it says v, I'm plugging in v plus h. So v plus h plus 2 minus, and then v over v plus 2. Okay, and again, we have this is a limit where the denominator has a limit of 0, and so I'm looking to eventually get rid of that h. Along the way, I think I have two fractions in the numerator, so the obvious thing to do is to get a common denominator up there. So I get the limit as h goes to 0 of, let's see if I can make it all work. Let's see, so in order to get a common denominator is v plus h plus 2 times v plus 2. So I'm looking to take what's here, v plus h, and on the bottom is v plus h plus 2. And I'm looking to multiply by top and bottom by v plus 2. And for the other one, I'm looking to multiply top and bottom by v plus h plus 2. So this is v times v plus h plus 2. Whoops, ran out of room there. And v plus 2 times v plus h plus 2. Okay, and I just got to do the best I can to try to cancel what cancels up top. So I think this is, I can't do this by eye. I'm gonna multiply it out. So I've got the limit as h goes to 0 of the whole fraction has a bottom of h, and I'm looking at the whole fraction up top has a bottom of v plus h plus 2 times v plus 2. Okay, so v plus h times v plus 2, so I'll multiply through by the v's first. I get a v squared, and there's a v times 2, 2v. Then there's an h times v, so that's hv. And then there's an h times 2. And over here I get v squared, vh, and 2v. I'm sure there must be some folks who can do this in their head, but I'm not one of them. So I see v squareds that cancel. This one I think it's safe to cancel, but I like to do it in a different color. I don't know, just everybody has their things. So I see a v squareds canceling. I see vh's canceling, vh and hv. And I see a 2v canceling, 2v canceling. So a whole lot of stuff went away. And I find myself looking at the limit as h goes to 0 of, I guess there's just a 2h up top. 2h over h. I mean, that's just 2. All over, sorry, 2h over, sorry. I put the h in the wrong place, over h. And v plus h plus 2, v plus 2. There we go. Made a little boo-boo, but I didn't let it get me. And here, there's the canceling, the 2h and the h cancel. And so there's a lot of smoke, but it's all clear. The limit as h goes to 0 of 2 over v plus h plus 2 all over v plus, times v plus 2. And now again, said it many times, can say it another couple times. So the difficulty with all these cases is that I had a limit. and the limit has an h in the bottom. So that makes the limit of the denominator equal to 0. And of course, I'm not allowed to do the limit laws in the case where the limit of the denominator is equal to 0. I have to figure out a way around that. And the way around that, I figured out what involved a certain amount of algebra. But now I don't have that anymore. Right now, if you take the limit here as h approaches 0, you get v plus 2 times v plus 2, so v plus 2 squared is no longer a denominator limit of 0. So I'm home free. I just get 2 over v plus h squared. Okay, and the limit expression went away because I'm no longer at a case. What did it wrong? V plus 2 squared. Sorry, what? My goodness. So I'm no longer at a case where I'm taking the limit. I was allowed to plug in h equals 0 because that denominator is non-zero. Okay, so 2 over v plus 2 quantity squared is the derivative of the original function. I think I get them both on the screen at the same time. Derivative of that is that. 2 over v plus 2 quantity squared. Okay. Okay, so it's not as simple as take the derivative of the top and the derivative of the bottom. It's much more complicated than that. Okay, again, I said it at the beginning, but I'll emphasize by saying it again. So I will often have folks tell me that there are many complicated steps here, and I'm having difficulty making my way through. Yes, I understand that. At least in my experience, my career, that this is the place where I first learned to do these extensive manipulations because I was required to do them in order to figure out the answers to these questions in the middle of this course. So this course required me to do them, so I learned how to do them. And I think for many other folks, you'll find that you do. Okay, so if you find these questions a little bit daunting, fair enough, but daunting and I'm not going to do it are two different things. Okay, very good, and so we'll see you for the next section. We're moving on to chapter 3, so very exciting.